Hi everyone, I'm Neha Deodhar. I'm an engineering manager on Cloud Spanner. Today I'm going to talk about how Cloud Spanner's unique architecture can help you build and scale your applications. Do you have an application with global reach or one with millions or even billions of users who need highly accurate, real time information? The database that powers your application can dictate your user's experience, your ability to grow, and your global resilience. Cloud Spanner is a highly available, strongly consistent relational database that is fully managed by Google Cloud. To understand how Spanner can help your application scale, be highly available and resilient, let's first understand Spanner's architecture. Spanner will automatically divide your data into chunks called splits. These splits contain data from your tables and indices ordered by the primary key. Spanner will distribute and balance the splits across multiple servers. As your data size or load increases, Spanner will automatically further split your data, merge some splits, or rebalance splits across servers. Spanner also creates multiple copies or replicas of your data. These replicas are stored across multiple zones and regions. It uses the Paxos consensus algorithm to keep the replicas in sync. One of the replicas is elected to be the leader. The leader replica is responsible for handling and replicating the writes. Transactions that read and write data from multiple splits will use an extra layer of coordination called two-phase commit. One of the split leaders that is involved in the transaction will act as the transaction coordinator and will ensure atomicity of the transaction. When your application writes data to Spanner, the write request is first sent to the split leader. The leader will record the write and will replicate it to the other replicas. When a majority of the replicas acknowledge the write, the transaction is committed. Now let's look at how you can configure your Spanner instance to achieve high availability. Primarily, Spanner has two types of configuration, regional configuration and multi-regional. In the regional configuration, Spanner will create 3 copies of your data and store them across 3 zones in a single region. This is a good configuration for applications that are regional or require low latency reads and writes, all within a single region. Using the Paxos consensus algorithm, Spanner is able to provide 4 nines of availability and even 0 RPO, 0 RTO recovery from various types of failures, like zone or network failures, machine or hardware failures. In the multi-regional configuration, Spanner will store multiple copies of your data across 3 or more regions. This is a good configuration for global applications or if you have applications that need to tolerate regional failure. It provides 5 nines of availability, which is Spanner's highest availability, and 0 RPO, 0 RTO recovery from region, zone, and other types of failures. Based on your application reach, you can also add read-only replica regions close to your users for faster reads. Now let's understand and try to unpack the various replica and read types that we've seen to get how you can use them to get the maximum benefit from Spanner. Multi-region configurations always contain 2 read-write regions and 1 witness region. The read-write regions each store 2 copies of your database. The witness only stores the transaction logs and does not store a full copy of your database. Spanner will require a majority of 2 out of the 3 regions to commit a write, or 3 out of the 5 replicas to commit a write. So these regions are usually located close to each other so that we can get reasonable write latencies. One of the read-write regions is designated to be the default leader region. Spanner will place all the split leaders in the default leader region. Having the split leaders in a single region ensures predictable and good latencies for transactions that involve multiple splits. You can change the default leader of your database to align with your application's traffic or your application's primary region if needed. Spanner's multi-region configurations also support additional read-only replica regions. These regions help you scale your application by keeping a copy of your data close to your users and providing low latency reads. Since read-only replicas do not participate in voting for writes, they don't impact your write latencies. Spanner supports two types of reads. The default is what we call as a strong read. This will always read the latest data. However, it may require communication with the leader to confirm that it has the latest data. In a multi-regional configuration, if the leader is in a different region than the replica that you're reading from, then your application might see higher latency due to the cross-region communication. If your application is latency sensitive and can tolerate slightly older data, then we recommend that you use stale reads. A stale read will read data at an older timestamp. For example, you can use a stale read with a maximum staleness of 15 seconds. Stale reads help you avoid communicating with the leader and can serve low latency reads. Now let's understand how Spanner's application architecture can help your application get high availability and global resilience. Let's consider a scenario where the leader region fails. Both zones and two copies of your data from the leader region will be unavailable in such a failure. In this scenario, replicas in the second read-write region will automatically be elected to become leaders. The leader change happens in the order of a few seconds. During this time, Cloud Spanner clients will automatically retry the intermittent failed requests. So your application will not see any downtime, even with region failure. Note that there could be a small increase in tail latency due to the leader election and client retries. When the leader region comes back up, the replicas in that region automatically will become leaders again. Now let's consider a non-leader region failure. There is no impact to application rights in this scenario. Spanner will continue to have three replicas, two from the leader region and one from the witness, available to form the majority quorum for writes. Reads that were previously being served by the replicas in the failed region will now automatically be served by the leader region replicas. So again, as before, your application will not see any downtime in a non-leader region failure. Now let's look at how Spanner handles zone failures. The split leaders in the leader region are distributed across two zones in the region. In the case of regional configurations where the leaders are distributed across the three zones in a region. When a zone in the leader region fails, replicas in the other available zones will automatically be elected as the leader. Again, your application will not see downtime. It may have a slight increase in write latency during the leader election and client retries. Spanner's unique architecture gives you the peace of mind that you have high availability, low latency, and resilience against failures. Businesses around the world are powering their users using Spanner. I hope that this presentation has gotten you excited about using Spanner for your application. To learn more or start using Spanner, please visit the Cloud Spanner page on Google Cloud. Thank you.